Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 9, using if-then moves in solving equations. Okay, classwork, opening exercise. Heather practices soccer and piano. Each day she practices piano for 2 hours. After 5 days, she practiced both piano and soccer for a total of 20 hours. Okay? For 5 days, total of 20 hours. Assuming that she practiced soccer the same amount of time each day, we already were told that each day she practiced piano for 2 hours. It says how many hours per day, H, did Heather practice soccer? Okay. So the first thing we want to do is represent H as hours playing soccer. Okay? Hours practicing soccer. Okay, so H equals hours practicing soccer. Okay, that's much better writing. Okay, so each day she practices piano for 2 hours. And we're talking about after 5 days. This is the key to the problem. We're talking about 5 days and doing the same thing every day 5 times. Okay? And practicing piano for 2 hours never changed, so we know that it's 2. So I'm just trying to piece all this together. And H is the hours practicing soccer, and it says that she practices soccer the same amount each day. So I'm just going to put H here for hours playing soccer. And we know the total is 20 hours. So that's going to equal 20. So 5 days practicing soccer plus 2 hours piano per day equals 20 hours. 20 hours. Okay, so now we're going to use the distributive property. And it's 5 times H, which is 5H. And it's going to be 5 times 2, so plus 5 times 2 equals 20. Okay? 5H plus 5 times 2 is 10 equals 20. And then what we're doing is we're using Pemdas backwards, and I will say that again. Very important that you get the hang of this. So here's Pemdas. Parentheses, exponent, multiply, divide, add, subtract. That is the order of simplifying expressions. But if we're going to solve equal signs, we work the opposite direction using inverses. Okay? So we're doing the inverse operations to cross an equal sign. So I have a plus 10 here, so we're going to add, subtract first, and there's an addition here. The inverse of addition is subtraction, so you subtract 10 from both sides. We have to do the same thing from to the left as we do to the right to make our equation still equal. If we have 2 bowls and we put M&Ms in each one, if I put one M&M in one, I have to put one in the other for the bowl to have the same number of M&Ms. Same concept here with keeping the equation equal. What I put in one equation, I have to put on one side, I have to put it in the other side, so it still is equal. So finally, when I have 5H plus 10 minus 10, these cancel, and I get 5H plus 0, or just 5H, equals 20 minus 10, which is 10. Then we're moving up the ladder here. We're getting to multiplication and division, and we have multiplication. 5H means 5 times H. The inverse, we're doing inverses. The inverse of multiplication is division, so I'm going to divide both sides by that 5 that H is being multiplied by. Dividing 5 divided by 5 cancels, or 5 divided by 5 is 1. 1H, 1 times H is simply H, so I'm just going to write H. And then 10 divided by 5 is 5. I'm sorry, 2. 10 divided by 5 is not 5. 10 divided by 5 is 2. Okay? So, Heather spent 2 hours practicing soccer and 2 hours practicing piano. Total 4 hours a day. times 5 days does equal 20. All right. Number 2. Over 5 days, Jake practices piano for a total of 2 hours, and Jake practices soccer for the same amount of time each day. Okay, so we're going to call H practicing soccer, hours practicing again. So rather than rewriting that and all that, here's what I'm going to do. I'm just going to go up here and put this here. So we're going to use the same variable. And H is the hours practicing soccer. The difference between the last problem and this problem is just the wording of this sentence here. Each day she practiced piano for 2 hours. Jake practiced piano for a total of 2 hours. Okay, so that's not each day, so I can't multiply that by that 5 like I did in the previous problem. He did not practice for 10 hours, 5 times 2. He practiced for 2 total. So this setup is going to be a little bit different. For 5 days, you practice soccer for the same amount each day. That I can easily write as 5 times H. But then practicing piano for a total of 2 hours is just plus 2. The difference between this problem here and this is the parentheses. We are not going to distribute that 5 to the 2 because he didn't practice 2 hours a day for 5 days. He just practiced a total of 2 hours. And that's going to equal 20. Okay. So I have 5H plus 2 equals 20. Again, we're doing Pemdas in reverse, doing inverses. So I'm going to do the inverse of plus, which is minus. Subtract 2 from both sides. And I'm going to get 5H. 2 minus 2 is 0, equals 20 minus 2, which is 18. I'm going to divide both sides by 5 because that's 5 times H, and the inverse of multiplication is division. 5's cancel, and I get H to equal, 5 goes into 18 3 times, that's 15 with a remainder of 3. Well, 3/5, if I wanted to convert that to minutes, or 3/5 would also be 3 6/10. But I wanted a decimal. It's 3.6 hours. Okay. If I want to convert it to minutes, then there are 60 minutes in an hour. And 5 times 12 is 60, so I have to multiply 3 times 12, which is 36. So it could be 3 3/5 hours, 3.6 hours, or H equals 3 hours, 36 minutes. Okay? Okay, example 1. Fred and Sam are a team in the local 138.2 mile bike run-a-thon. Fred will compete in the bike race, and Sam will compete in the run. Fred bikes at an average speed of 8 miles per hour. Okay? And Sam can run at an average speed of 4 miles per hour. The bike race begins at 6 a.m., followed by the run. Sam predicts he will finish the run at 2:33 a.m. the next morning. A. How many hours will it take them to complete the entire bike run-a-thon? Okay? We're talking about the prediction here. So we're starting at 6 a.m. So let's call that 0600 for us military time and European time. So 0600 hours is AM. And if we go to 0600 PM, no such thing, that is 1800. Okay, that's a total of 12 hours. If I go from 1800 to 2400, or 0 hour, okay, 18 to 24 is 6 hours. And then from the 0 hour to the 2:33 a.m. approximation is that 2 hours and 33 minutes. So how many hours will it take them? It's addition. So it's 12 plus 6, which is 18, plus 2, which is 20. 33 minutes. Okay. I could also put this as a decimal. Okay. And if I do a decimal, it's 33 minutes out of an hour. And if I reduce that, 3 will go into 33 11 times, and 3 will go 60 20 times. Okay, so if I divide that by 2 to get down to a tenth, it's 5.5 or 20.55 hours. Okay, B. Let's take this right here. If T is how long it takes Fred to complete the bike race in hours, write an expression to find Fred's total distance. So we're going to use the distance formula, which is D equals rate times time. D equals R times T. And in this case, we want to know what the rate of, we're talking about Fred biking, his rate is 8 miles per hour. So you take that 8 times time to determine the distance. So if I want an expression of Fred's total distance, the expression is not an equation. The expression is just simply what the distance is equal to. There's my expression, T. Part C says, write an expression in terms of T to express Sam's time. Okay? Well, if we're going to use the total, 20.55 hours, we want to express Sam's time. That's the total time. 20.55 minus how long it's going to take in terms of time, in terms of T here, whatever his time is. An expression in terms of T to express Sam's time. Okay? Sam's time would be 20 hours, 20.55 hours minus T. D, write an expression in terms of T that represents Sam's total distance. Okay, so now we're kind of doing the same thing as we did in B, but now we're doing it for Sam. So we're going to use that D equals rate times time again. And in this case, D equals our rate, which is 4 miles per hour. That's his rate. Times time, which is right here, to express Sam's time. Run expression represents Sam's total distance, so we want to take his rate times his time, which is 20.55 minus T. Okay, or I could also say that distributing 4 times 20.55 is 5 times 4 is 20, 5 times 4 is 20, carry the 2 is 22, carry the 2, 4 times 0 is 0 plus that 2, 4 times 2 is 8. Okay, so we have 82.20 minus 4 times T minus 14. Okay. Okay, I just wanted to rewrite that a little bit here. Okay, now E says write and solve an equation using the total distance both Fred and Sam will travel. Okay, Sam traveled a distance of 8t plus 82.2 minus 4t equals 138.2. Okay, that came from the distance they're going to travel, which is right here, 138.2, bike run-a-thon. Okay. Now I just need to simplify this, and I'm trying to find out what t is. So the first thing I'm going to do is combine like terms. I always want to make sure I have this simplified down on one side. And I have an 8t minus 4t, which is 4t, plus 82.2 equals 138.2. So now I've got this simplified, and now I'm going to do Pemdas in reverse using inverses. 82.2 minus 82.2 minus 82.2, and I'm going to get 0, 6, and 13 minus 8 is 5. Equals, these cancel, and I just bring down this 4t. In order to finish this, I do the inverse of multiplication, which is division, and 4 divided by 4 is 1, leaving 1t or simply t. 4 goes into 5 once, 4 goes into 16 4 times. So t equals 14. Okay, so what is t? If I come back up here, t equals 14 would be what? Fred's time, right? This is Fred's time. Okay. Sam's time would then be that 20.55 minus t okay, so I'm going to move this over here now. Okay, this is Sam's time we're working on. 20.55 minus t, and I know t is 14, so it's going to be 20.55 minus 14, okay? And it might be easier for you to do it this way. Line things up. 5 minus 0 is 5, 5 minus 0 is 5, 2 to 1, 10 minus 4 is 6. So Sam's time is 6.55 hours. Fred's was 14 hours. Okay. F. How far will Fred bike, and how much time will it take him to complete his leg of the race? Okay, so Fred, if you remember, is 8t. His distance is 8t. Remember, d equals r times t, and we had d equals 8t. That's Fred's biking. How much time will it take him to complete his leg of the race? It's 8t, which is 8 times 14, and 8 times 14 is 112. Okay, so that's distance. How far will Fred bike? So remember, it's d equals rt, d equals the rate, 8 miles per hour, times 14 hours. He will go 112 miles on his bike. And it says, and how much time will it take him to complete his leg of the race? And we've already answered that. That's what the t is, 14 hours. How far will Sam run? Distance equals 4 times 20.55 minus t. Okay. Substitute. D equals 4 times 20.55 minus that 14, which is our t. And so D equals 4 times 6.55, which we got in the last part. And that equals 26.2 miles. Okay. Which is a typical marathon. 26.2 miles is a marathon, and I believe 112 miles is how far someone bikes when they do an Ironman competition, and therefore this bike-a-thon, bike and run-a-thon is the same distance as used in marathons and Ironman. Okay. So next thing is we have a table. Total time in hours, Fred's time in hours, Sam's time in hours. So if we take the total and subtract Fred's, we're going to get Sam's. So we're subtracting. That's all we're doing, subtracting. So I'm going to write 10 minus 6 equals 4. 15 minus 12 equals 3. 20 minus 8 equals 12. 18.35 minus 8 equals 8.35. And 20.55 minus t cannot be simplified unless we know what t is. Okay, so another way we can do this is set up a table. What are we dealing with? We're dealing with two people, Fred and Sam. And this area does not get used. Okay, and we're talking about how fast each one is going, rate, how long it took them, time, distance they went. So this is miles per hour. This is hours. And this is miles. Okay. So Fred's rate was 8 miles per hour. Sam's was 4 miles per hour. Fred took 14. But let's put it in terms of variable first. T, and this is 20.55 minus T. So the distance is rate times time, 8 times T. Rate times time, 4 times 20.55 minus T. Okay, I'm just showing you a different way to do this using a table of values. We have rate, time, distance, we have Fred, we have Sam. You can set it all up in a table and organize it much better than step-by-step process. So here's example 2. Shelby is 7 times as old as Paul. So we have Bonnie. And we have Shelby. I'm going to use this. Okay. So it says, if in 5 years the sum of Bonnie and Shelby's age is 98, find Bonnie's present age using algebraic approach. So we were talking about 2 things. Find Bonnie's present age, and we're talking about in 5 years, future. So present age. Okay, and then future age. Alright, so that's what we're setting up. Right, so now it says Shelby is 7 times as old as Bonnie. So that's present time right now. So we don't know Bonnie's age, so let's call it X. And Shelby is 7 times as old as that, or 7 times X. In future, in 5 years, the sum of Bonnie and Shelby's age is 98. So in 5 years, if Bonnie is X years old, in 5 years she'll be X plus 5 years, and Shelby will be 7X plus 5 years. Okay, so now that we've done this, it says if in 5 years the sum of Bonnie and Shelby's age is 98, in 5 years, that's future, so we're focusing on this piece, their sum, X plus 5 plus 7X plus 5 is equals 98. I'm going to combine my terms. So I have an X and I have 7X. So that's 8X. I have plus 5 plus 5, which is plus 10, equals 98. Pemdas in reverse, doing the inverse of addition is subtraction. Subtract 10, subtract 10. Remember what we're trying to get by itself, that X. Get this away from it and then get that away. We're going to be left with 8X. Those cancel. 98 minus 10 is 88. This is multiplication. The inverse is division. 8's cancel. X equals. Okay? So that is X. That's Bonnie's present age. Bonnie's 11 years old. Okay? Did we answer the question? Find Bonnie's present age. If it said find Bonnie's age in 5 years, then it would be 11 plus 5, 16. We could now find Shelby's age. She's 7 times as old as Bonnie. She is 77 years old, so she's probably possibly Bonnie's grandmother. And in 5 years, 77 plus 5 is 19. That's the end of lesson 9. Your problem solved.